Hello everyone, in today's video we're carrying on with electrophilic addition mechanisms, and now we are having a look at the electrophilic addition of hydrogen bromide. And as before, we have two things to look at with electrophilic addition. We need to have a look at the actual mechanism, and we need to have a look at the reaction conditions, because you can be questioned on both in the exam. So let's start with the mechanism. It's electrophilic addition, so we're adding across an unsaturated functional group a carbon-carbon double bond, and it's electrophilic attack. An electrophile is something that is electron deficient and is attracted to this high concentration of electrons within the carbon-carbon double bond. Now, in our last video on the electrophilic addition of hydrogen gas, we saw we had to induce a dipole, but as you will all know, hydrogen bromide is a polar molecule, with bromine being slightly more electronegative than hydrogen. So in this case, we always write our hydrogen closest to the double bond and our bromine furthest away, because we're not inducing a dipole. That dipole already exists, with hydrogen delta positive, slightly electron deficient, bromine delta negative, slightly electron proficient. And we draw our curly arrow coming from the double bond, equidistant between the double bond and the delta positive hydrogen. We draw our second curly arrow going from the electrons in the bond, in the hydrogen-bromine single bond, going to the bromine atom. And this is our first step. This is the electrophilic attack, and it is the rate-defining step because it is the slowest step. And we form our carbocation, which is a positively charged intermediate ion with a positive charge on the carbon. And what are we left with? Well, we're left with a bromine ion. It now has a lone pair of electrons and a negative charge. And as we all know, there's an attraction between positive and negative, so this lone pair is going to come and form a single covalent bond, equidistant between the carbon and the bromine, forming our final product, which is in this case bromoethane. It's a haloalkane, and it is fully saturated. And remember, as before, we need two curly arrows and two partial charges in the first step, two full charges, one curly arrow and a lone pair in the second step. And the second step is a fast step. That has nothing to do with the overall rate of reaction. Again, in the exam, you might be asked to identify what the electrophile is. The electrophile is not hydrogen bromide. The electrophile is the delta positive hydrogen of the hydrogen bromide. And you won't get marks for saying that it's the hydrogen bromide. You have to say it's the delta positive hydrogen. So the next thing to do is to have a look at the reaction conditions. And it's nice and easy with hydrogen bromide. All we want is hydrogen bromide in a polar solvent. And remember, water is a polar solvent, so that's really just hydrogen bromide aqueous, and the reaction to occur at room temperature. We have no need for a catalyst. And that's it. We've cracked the mechanism for the electrophilic addition of hydrogen bromide across a carbon-carbon double bond in an alkene unsaturated functional group. Now, if this has helped you, do feel free to check out our other electrophilic addition mechanisms, and feel free to give this a share with anyone who you think this might help. Thank you.